What I have on the board here is called the change of base formula. And what this is telling me is if I have log of x base anything, base 2, base 5, base 17, base 2.34, whatever, I have the capacity to change to any base I want to change it to. And the two bases I'd want to change to be either ln or log, because that's what my calculator knows. Okay, so I'm allowed to do this. So what I'm telling you here, and I don't know what this stray mark is there, just pretend that's not there, that's just block that. Let's see. I think the only way I can block it out is to just put like a little rectangle over top. There we go. Straight marks like that don't erase. Alright, anyway. For me personally, I go to one of these two forms here. Either log, which is base 10, or lm, which is base c, because again, those are the calculator ones. And the change of base formula simply says to do log of x base b, you do log of x over log of b, or ln x over ln b. Okay. You do the log of the argument on top, you do the log of the base on the bottom. That's equivalent to log of x base b. To prove it, it's really easy to prove. We know, let's say, here, let me just do this one. If I do log of 8 base 2, that equals 3, right? Because 8 is 2 cubed, so log 2 cubed base 2. So just based on our rules we've already learned. So we know the answer to that problem is 3. So I'm telling you, if I do log of 8 divided by log of 2, I should get 3. If I do ln of 8 over ln of 2, I should also get 3. We test it out. Log 8 in parentheses divided by log 2 in parentheses equals 3. ln 8 parentheses divided by ln 2 in parentheses equals 3. If you do log on top, L on the bottom, that's no good. You got to do the same one. All right. So whatever you choose to use, ln or log, go with that. My favorite's ln because there's one less character to write. Yeah. Log is 3 characters, ln is 2. If there's e's involved, I always go ln. If there's tens involved, I always go log.
So how does that work? Is that just assuming that x divided by b is...
It's just magic.
Well, I don't know.
At this point, just believe it. Okay, it'll be magical stuff for you. But for right now, you just believe it to be true. All right. I'll investigate the y's. I'm sure there is a y, but I don't have it right off the top of my head. So, but yeah, there's a reason why it works.
Yeah.
Evaluate each logarithm round to the nearest 100,000. So what we're looking at, of course, is logarithms to bases that aren't 10 or e. Our calculator typically can't do it. Obviously, if I try 3 to the first is 3, times 3 is 9, times 3 is 27. 18 is not 9 or 27, so we can't do it the way we've been doing it, right? So it's not possible to do it how we've been doing it. So all I can do is come here, and we know that, always in front here, according to the change of base rules, that log of 18 base 3 is equivalent to the natural log of 18 on top over the natural log of 3 on the bottom, or again, log if you wish. I prefer ln because there's one less character to write. It saves myself writer's cramp. So if I type in ln 18 on top divided by ln 3 on the bottom, that comes out to 2.63092974. Said round to the nearest 100th or 100,000? 100,000. All right, so tenths, hundredths, thousands, 10,000, hundreds, so 5 decimal places. 2.63093. These are easily checked if you recall what a logarithm is. If this right here equals that, right? That means 3 raised to that power equals that number, right? So if we try it out, 3 caret 2.63093, it's going to be slightly bigger than 18 because we rounded up, right?
Yeah.
Slightly bigger than 18. All right, that verifies, in my opinion, that it's the right answer. All right, but again, that's an easy way to check. The base raised to the power that you got should equal the argument. All right. Same deal for part B, log of 400 base 12. Again, if I do 12 times 12 is 144 times 12 again is like 1728. Skipped 400, right? So can't do it with power rule. So log, natural log of 400 over the natural log of 12. It's just a matter of typing that in our calculator. ln 400 on top divided by ln 12 on the bottom. And that comes out to 2.411142707. Again, nearest 100,000, that's 5 decimal places, 2.41114. In this case, if I did 12 12 raised to that power, I should expect something slightly less than 400 since we rounded down, right? So if I typed in 12 caret 2.41114, that comes out to 399.997, slightly less than 4. Okay, 400. So again, that's very easily checked. Anytime you do a logarithm, just verify that way. The only thing I've seen people mess up on, they type 400 and they miss one of the zeros maybe. I mean, it's usually entering the calculator improperly. LOG on top, LO on the bottom, something like that.
Yeah.
I find if you write it on your paper, you're less likely to do that. So those are the types of mistakes that are made, but just pay attention to detail. They're not terribly difficult.